Determine the values of x for which mod 2x plus 5 take away mod 1 minus x is less than 1. I'm going to try and sketch this, and that's going to take a little bit of work. So, here's my y and here is my x. So if we consider just this, y equals mod 2x plus 5, we know that that one has its 0 at negative 5 on 2. Then it's going to go like this, and this branch here would be y equals 2x plus 5, and then over here it's going to go like this, and this limb over here is going to be y equals negative 2x take 5. Now let's consider the 1 minus x. Well, the 0 there is at 1, and then that is going to go from there, it's going to go like this, and like this. And this bit would be y equals x take away 1. And this bit over here would be y equals 1 minus x. Okay, so now let's think about that together. What happens when x is less than negative 5 over 2? Y is going to be negative 2x take away 5, take away 1 minus x. So basically it's going to be that take away that. Those are the equations of the limbs of the lines in that region. So that's going to be negative 2x take away 5, take 1 plus x, which is negative x take away 6. Now let's go in between. So we are going to go x is more than negative 5 over 2, but less than 1. So in there we have 2x plus 5, and we still have the 1 minus x. So that is going to be 3x plus 4. And then let's look, so let's just make it clear what we're doing here. And then we've got the x is greater than 1 region. And that means we've got this one and this one. So y would be 2x plus 5 take away x minus 1. So y is going to be 2x plus 5 take away x plus 1. Y is equal to x plus 6. Now we're after intersects with y equals 1. So for the x less than negative 5 over 2 region, I'm going to have negative x take away 6 is equal to 1. That gives me negative x equals 7, and so x equals negative 7. And that's perfectly valid because it's in this region. If we go for the x more than negative 5 over 2, but less than 1, we'll have 3x plus 4 is equal to 1. 3x equals negative 3. X equals negative 1, and that's valid because it's in this region. But when we look at the x is more than 1 region, if we do x plus 6 is equal to 1, that gives me x equals negative 5. That's not valid because negative 5 is not in the region that's greater than 1. Anyway, let's try and sketch this situation, and we'll come back and look at these things that I found here, and that will show you that we don't actually need to do this final sketch. So I'd like to do the sketch though so that we can see what's going on here, and what a strange looking thing we get with this mod 2x plus 5 take away mod 1 minus x. So we said for x is less than 5 over 2, negative 5 over 2, that the graph is y equals minus x minus 6. So if you put y equals 0 there, that's x equals negative 6, so it's going to have an x-intercept here. We know it's going to have a negative gradient, and when x is negative 5 over 2, we've got y is equal to 5 over 2 take away 6, which is negative 7 over 2. So it will come down to here somewhere. It's only a sketch, we don't need to be accurate. And so we've got that for x is less than 5 over 2. Now, for x between negative 5 over 2 and 1, we had 3x plus 4. So this one is going to go as far as 1. Now think about 3x plus 4. If x is negative 5 over 2, so we've got 3 times negative 5 on 2 plus 4. So that's negative 15 on 2 plus 8 on 2, which is 7 on 2. So it joins up to the same point. Now when x is 0, this would be equal to 4. And then that section is going to stop when x is 1. When x is 1, y is 7 there. And then we've got another region that says x plus 6. So it is going to join up when x is 1, x plus 6 is 7. And so that one is going to go off like that. And that's what our graph looks like. And then if I draw y equals 1 onto here, we can see that we get two intercepts. One of them in the region less than negative 5 over 2, one of them in the region negative 5 to 1, which is what we found with the analysis here, which is why you actually don't need the sketch. But now that we have that, we can see that the curve, which one are we looking for? We're looking for this to be less than 1. So we're looking at where our modulus graph, this is the graph that we're talking about here, the modulus one, we're looking at where that's less than the pink line. And that is going to be between the intersections here and here. It was a strictly less than, and we found with our analysis that those intersects were at negative 7 and negative 1, and so we can say that x is more than negative 7 and less than negative 1.